Alright, 8.3. Show that a quadrilateral is a parallelogram. Okay, there are a couple different ways to show that a quadrilateral is a parallelogram. If both pairs of opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. So for example, in this four-sided figure, if AB is congruent to CD and BC is congruent to AD, then you know it's a parallelogram. Also, if both pairs of opposite angles of a quadrilateral are congruent, then the quadrilateral is a parallelogram. So in this case, if angle A is congruent to angle C and angle B is congruent to angle D, then you know it's a parallelogram. So for example, in the diagram at the right, AB and DC represent adjustable supports of a basketball hoop. Explain why AD is always parallel to BC. So this is what we have. We have this quadrilateral. It can move up and down, it looks like. They want to know, why is AD always going to be parallel to BC? The shape of quadrilateral ABCD changes as the adjustable supports move, but its side lengths do not change. Both pairs of opposite sides are congruent. So, ABCD is a parallelogram by theorem 8.7. By definition of a parallelogram, AD is parallel to BC. Alright, page 2. Okay, if one pair of opposite sides of a quadrilateral are both congruent and parallel. Okay, so if in this case AD and BC are congruent and parallel, then the quadrilateral is a parallelogram. So if these are congruent and these are parallel, parallelogram. You don't need to know anything about the other two sides. Also, if the diagonals of a quadrilateral bisect each other, then the quadrilateral is a parallelogram. So if BD and AC bisect each other, it's a parallelogram. So for example, the headlights of a car have the shape shown at the right. Explain how you know angle B is congruent to angle D. Okay? Now, in the diagram, BC is parallel to AD. That's what those little arrows mean. And BC is congruent to AD. By theorem 8.9, quadrilateral ABCD is a parallelogram. Now, because it's a parallelogram by theorem 8.4, that's what we learned in the last section, you know the opposite angles of a parallelogram are congruent. So angle B is congruent to angle D. By the way, if you don't remember the numbers of theorems, you can just write out what the theorem says. That's fine with me. I just wrote the numbers out because it's a little bit shorter, but on a test or on an assignment, if you just want to write down what the theorem says, you don't have to remember the numbers. I'll be honest, I don't remember all the numbers either, okay? So it's more important to me that you know what the theorem says than you know the number of a theorem, okay? Alright, page 3. For what value of x is quadrilateral PQRS a parallelogram? So, they want to know, what does x have to be for this to be a parallelogram? By theorem 8.10, if the diagonals of PQRS bisect each other, then it's a parallelogram. You're given that QT is congruent to TS. You need to find x so that PT is congruent to TR. Because if you already know that this is congruent to this, if this is also congruent to this, then they bisect each other, which makes this a parallelogram. Alright, so let's imagine PT equals TR. That would mean that 5x equals 2x plus 9. I substituted 5x for PT and 2x plus 9 for TR. Let's subtract 2x from each side. These cancel out. I get 3x equals 9. I'm going to divide each side by 3. Oop, you know what? I wrote x twice. There we go. Divide both sides by 3. X equals 3. So, when x equals 3, PT equals 5 times 3, which is 15. And RT equals 2 times 3, 6, plus 9, which also equals 15. So, quadrilateral PQRS is a parallelogram when x equals 3. Alright, this is a good thing to memorize. Okay, these are 5 ways to show that a quadrilateral is a parallelogram. First, opposite sides are parallel. Second, opposite sides are congruent. Third, opposite angles are congruent. Fourth, one pair of opposite sides are congruent and parallel. And then, of course, diagonals bisect each other. If you can prove any one of these 5 things, automatically you know it's a parallelogram. You don't have to show anything else to prove it's a parallelogram. That is sufficient info. Okay, show that quadrilateral KLMN is a parallelogram. Now, there are different ways you could do this. You could use the distance formula to find all 4 of these sides and then prove that opposite sides are congruent. For this example, we're going to show that one pair of sides are congruent and parallel. Okay, and then after that, we will apply theorem 8.9. So first thing we have to do, we need to use the distance formula to show that the sides are congruent. Okay? KL, that's this here. Close enough. Okay, KL and MN. Okay, the points are given. I'm just going to plug them into the distance formula. If you don't remember the distance formula, I'll write it over here. x2 minus x1 squared plus y2 minus y1 squared. There you go. So, when you plug these in, you're going to get 4 minus 2 squared plus 4 minus 2 squared. 4 minus 2 is 2. Squared is 4. I'm going to add in a step over here. So you have 4 plus 4. So you have the square root of 8. Mn, I'm going to plug in those points. 6 minus 4 squared plus 0 minus negative 2 squared. I'll add another step. 6 minus 4 is 2 squared. Minus negative becomes a positive. 2 squared again is 4. So we have the square root of 8. Because they're equal, because they both equal root 8, they're congruent. So, we've shown they're congruent. Now we just need to show they're parallel. Now remember, parallel lines have the same slope. So we're going to use the slope formula to show that these two segments, these two sides, are parallel. Okay, let's take a look at the slope of KL. Now, the slope formula, hopefully you guys remember, is rise over run. Another way you could write it is y2 minus y1 over x2 minus x1. This is something you learned in algebra, and we kind of went over it this year also. So if I plug in these 2 points, I've got 4 minus 2 over 4 minus 2, which is 2 over 2, which is 1. Now let's do the same thing for Mn. We've got 0 minus negative 2. 6 minus 4, minus negative becomes a positive, so once again we have 2 over 2, which is still 1. They have the same slope, so they are parallel. KL and MN are congruent and parallel, so KLMN is a parallelogram by theorem 8.9. Or you could write out because one pair of sides are congruent and parallel. Alright, I'll let you guys do the checkpoint, and that's all.